So, dear students, now we are going to commence with the study of group 16 elements in the inorganic chemistry. So, whenever we come across the title group 16 elements, we generally say oxygen, sulfur, silurium, sorry, oxygen, sulfur, selenium, tellurium, polonium. Among these elements, it is very well known that the general electronic configuration for these set of elements is Ns2Np4. As and when we write Ns2Np4, we are quite aware of the thing that there are 6 valence electrons, and if we want to fill up these electrons, it is very easy for us. Over here we will always write 2s2 2p4, 3s2 3p4, 4s2 4p4, 5s2 5p4, and 6s2 6p4. So this is how we come up with the electronic configuration of group 16 elements. Now, in this group 16 elements, it is also essential for us to know that what are the sources from where these elements are obtained. So when it comes to sources, if you see over in the category of occurrence, it is written that oxygen forms about 46% by mass of the earth crust, and dry air contains somewhat around 21% of oxygen by volume. However, the abundance of sulfur in the crust of the earth is only 0.03 to 1%. Combined sulfur exists primarily as sulfates, and those popular sulfates, as we know, is calcium sulfate, we call it gypsum salt, and also we have magnesium sulfate, we call it Epsom salt. But we are very much versed in learning that when we say calcium sulfate, we must always mention 2H2, and when we say magnesium bearing Epsom salt, we must always mention 7H2. Above from these two, baryt, that is BaSO4, is also one of the very important source of sulfur, along with several sulfides like PbS, that is galena, ZnS, that is zinc blende, and FeS and CuS mixture, which is generally called CuFeS2, which is also popularly known as copper pyrites. So these are few very important sources which deliver sulfur in a very good amount. Let it be calcium sulfate 2H2O, magnesium sulfate 7H2, or these few rest that we are all discussing now. Going further in this same streamline, over here it is very well mentioned that selenium and tellurium are also found as metal selenides and tellurides in the form of sulfide ores, and polonium occurs in nature as a decay product of thorium and uranium. So over here we are aware, or rather not, we should be aware from now, that polonium is a radioactive daughter element. Whenever we use the word daughter element, we must know that either thorium or uranium on radioactive decay gives polonium. So this is how we can discuss about the sources from where we are made available with these important elements which are under study. Now we are going to start with the discussion of physical properties. Whenever we coin the word physical properties, we generally discuss atomic mass, atomic radii, ionic radii, ionization enthalpy, electronegativity, electron gain enthalpy, and many more. But these are very few important physical properties where you can also include density, boiling point, and melting point. So students, our first task now will be identifying these properties in the group 16 and also learning their trends. One more very important thing that can be included over here is the group 16 made up of oxygen, sulfur, selenium, tellurium, and polonium, which we are discussing now, is popularly known by the term chalcogen. Is popularly known by this term chalcogen. So now we will start with physical properties that are made available to us. We will first shortlist these physical properties on the basis of this tabular format every time. And once we are done with the tabular format, we will go with the theory. So, first of all, learning the atomic mass property in this group 16 chalcogens, we are very much clear that for group 16, that is chalcogens, coming down the group, that is oxygen, sulfur, selenium, tellurium, and polonium, the property of atomic mass increases continuously. If you look to the values given over here, atomic mass is constantly increasing from 16 gram in oxygen to 32 gram and so on. Similarly, going on the same basis, if we check for the ionic radii and atomic radii, we can very well pinpoint that ionic radii and atomic radii are increasing constantly as we move down the group, that is from oxygen towards polonium. Over here, you can very well identify and indicate that the difference in atomic and ionic radii between oxygen and sulfur is large, whereas the difference in atomic and ionic radii between sulfur and selenium, selenium and tellurium and polonium are comparatively low. So, keeping in mind these large and low differences in the atomic and ionic radii, the very well designated reason would be the absence of d orbital in the filled state in oxygen and sulfur does not shrink its radii. But when the d electrons are found filled in selenium, tellurium, polonium, it is definite to say that due to n-1 filling of D and at a later stage n-2 filling of F, there is a shrinking in atomic radii and ionic radii, and hence the difference in the radii decreasing as we move down the group. Mind well, I am speaking the word difference in the radii decreases, although atomic and ionic radii increases down the group. So once we are done with atomic mass, ionic radii, atomic radii, one more important point that comes over here along with these three is the property of being metallic and being non-metallic. Yes, before we go on discussing the property of being metallic and being non-metallic, I would like to draw your attention that covalent radii, which is mentioned in your reference, is nothing else but equivalent to atomic radii for the concept of radius. Now, coming back to the point, metallic radii and non-metallic radii. Over here, I would like to mention that going down the group, the metallic property increases. If the metallic property is increasing, down the group, it is quite clear that the non-metallic property should decrease. So with the increment in metallic property, it is quite clear that the non-metallic property is decreasing. So we can very well say that in the group 16, with the increasing metallic property down the group, the non-metallic property decreases down the group. So once we are done with atomic mass, atomic radii, ionic radii, and the property of being metallic and the property of being non-metallic, let us take straight away a very small property of electronegativity. We know that as the radii increases, it is difficult for an atom in a shared molecule to access or to attract the shared pair of electron towards itself. Hence, moving down the group in 16, atomic radii increases and therefore the tendency to attract the shared pair of electron decreases, resulting in decreasing value of electronegativity based on Pauling scale. So, electronegativity decreases down the group. So, over here, friends, electronegativity decreases down the group, non-metallic property decreases down the group, whereas atomic radii, ionic radii, atomic mass, and the property of being metal increases down the group. In the same phenomena, when we have the data of atomic mass, let us find out the trend in density. So when it comes to density, very well mind that density is equal to weight by volume, and when density is equal to weight by volume, with the increase in weight or with the increase in mass, density increases because it is directly proportional to weight or directly proportional to mass. So going down a group, if the atomic mass increases sharply, make it very clear that the density also increases sharply. So going down the group, from oxygen to sulfur to selenium to tellurium to polonium, the concept of density increases. So if you look over into the tabular format, we are done with atomic mass, covalent radii, ionic radii, electronegativity, density. Now we are going to talk about a very important property, and that is ionization enthalpy. Ionization enthalpy, as we know, is the minimum amount of energy required to remove an electron from an atom in its gaseous state from its outermost orbit. Going down the group, that is from oxygen to sulfur to selenium to tellurium to polonium, we can see that the atomic radii increases, and resulting to which the attraction between the nuclei and the electron in the outermost orbit decreases. So if the attraction is less, it becomes very easy for us to remove an electron from the outermost orbit or shell, and hence going down the group, we know that atomic radii increases. Henceforth we can say that attraction decreases, and when we say attraction decreases, it becomes easy to remove an electron, and when it becomes easy to remove an electron, we can very well say that ionization enthalpy also decreases down the group. So this trend is observed regarding the decrement in the ionization enthalpy when we are discussing the group 16, popularly known as chalcogens. Moving into detail with a property of electron gain enthalpy. As you have studied group 17 and group 18, you are now very much clear with what electron gain enthalpy is. It is that amount of energy which is thrown out from an atom to gain stability only and only after it accepts electron to complete its octet. If you look in this way, we know that oxygen is the smallest, so it will lose less energy to catch an electron. Henceforth, it will be left with a very huge energy to throw out, and hence oxygen should throw a maximum energy out. But the trend is not the same. Now, the reason is oxygen is a small in size atom. When it is a small in size atom, its radii and the circumference of the second orbit is also small, and that orbit has 6 electrons eventually. So when the 2 electrons try to come in, they are little bit repelled by the electron present in this second orbit due to smaller circumference, and therefore they go out again. So to bring them back inside, nuclei bearing proton has to waste a lot of energy to catch them, and hence when a lot of energy is wasted in catching them, very less energy is left which is then thrown out, and henceforth, to your utter surprise, the electron gain enthalpy value negatively for oxygen is least. Pardon, it is not plus, it is minus 141 kilojoule per mole. So when in the terms of the negative value of electron gain enthalpy for group 16, popularly known as chalcogens, we can say that the value decreases down the group, and therefore sulfur, selenium, tellurium, polonium, and at last oxygen comes. This value I am writing in a mode negatively decreases. It means sulfur has maximum negative, then comes selenium, then comes tellurium, then comes polonium, and then comes oxygen. So negatively decreases. But if we speak positive, then you have to go inverse and say that it increases. So this is how the things work. And you can now say that electron gain enthalpy decreases down the group negatively with an exception in oxygen. So this is how we are gathering few physical properties starting from atomic radii and coming up to electron gain enthalpy. Moving in the same direction, we have two more values, that is the melting point and the boiling point. So when it comes to melting point and boiling point, make it very clear that here let it be melting point or let it be boiling point. You have one exception, and that is polonium tellurium exception. Let it be melting point or let it be boiling point, the maximum value is always tellurium. Tellurium has a higher melt point as well as boiling point compared to polonium. And once this exceptional is reversed, it is written properly, then you do not have to worry. The rest thing are very clear. Oxygen, sulfur, selenium, you have no exceptions. So you can see that let it be melting point or let it be boiling point, the least value belongs to oxygen. A little higher than oxygen is sulfur, a little higher is selenium, then comes polonium, and the highest is tellurium. Let it be boiling point or let it be melting point. Now coming to the concepts of oxidation state. Mind very well that whenever you use the word oxidation state, going down the group, that is group 16, going down the group, that is group 16, always the oxidation state value -2 and +6 decreases, whereas the value +2 and +4 increases. How can this be justified? you see over there in the table, polonium is found to have plus 2 and plus 4. It means plus 6 is missing and minus 2 are missing. So going down the group, these two are missing. But initially you did not find plus 4 in oxygen. But when you moved forward from sulfur to selenium to tellurium to polonium, plus 4 was there. Therefore, over here you can say that in the terms of oxidation state, minus 2 and plus 6 decreases down the group, whereas plus 2 and plus 4 increases down the group. Now, why oxygen cannot have plus 4 or plus 6 oxidation state? And the answer to that is the absence of d orbitals do not allow oxygen to cross its oxidation state of plus 2. Another interesting fact over here is if it is oxygen, how can you have plus 2, plus 1, minus 1 and minus 2 possible? OF2 oxygen is plus 2, O2F2 oxygen is plus 1, H2O2 oxygen is minus 1 and H2O oxygen is minus 2. So these are the four molecules where you can have oxygen with its respective range of values from minus 2 to plus 2, and O2 or O3 always mentions its oxidation state to be 0. So this is how you can justify the oxidation states. The discussion that we did through this table is all mentioned very well over here. I am not going to read line by line because I will leave it to you. So if you read, you will have questions, and on the basis of that questions you will ask me. But ionization enthalpy is a point where it is written that ionization enthalpy decreases down the group. It is due to the increase in the size. But now there is an important point. However, the elements of this group have lower ionization value of that of 15th group. Now see, group 15 and group 16 are two different things. So generally what happens, going from left to right, ionization enthalpy should increase because the size decreases, and therefore the elements of 15 should have low value and that of elements of 16 should have high value. But over here it is different. Look properly. 15th group has higher value and 16th group has lower value. This is because in the 15th group, if you check the general formula, it is NS2NP3. And when it comes to NP3, mind well dear students, it is a half-filled suborbit which is more stable. Therefore, NP3 is more stable than the current group 16NP4, and therefore the elements of group 15 have higher ionization enthalpy than that of group 16. So this was an exception. Remember it very well. You have already learned the exception of electron gain enthalpy. Over here, if you see in the physical properties, you are very much versed that oxygen and sulfur are non-metals. Selenium and tellurium are metalloids, whereas polonium is a metal. Polonium is a radioactive metal, a product of thorium or uranium on radioactive decay with a half-life of 13.8 days. All these elements exhibit allotropes. You know, when an atom combines with the same atom and forms a molecule, we call it allotrope generally. Ozone is an allotrope. S8 is an allotrope. These are the things how allotropy comes into existence. Melting and the boiling point increases with the increase in the atomic number down the group. There is a large difference between the melting point and boiling point of oxygen and sulfur. Oxygen exhibits as a diatomic molecule, that is O2, whereas sulfur as S8. We have already learned about the oxidation states in the table. Now comes another important topic where it is chemical properties along with the oxidation states. So when you see the chemical properties with the oxidation state, make it very clear what we have already learned, that oxygen is from minus 2 to plus 2. We have also the values present here, it is given minus 2. So see, the stability of minus 2 decreases down the group. It shows only since electronegativity of oxygen is very high. You can also see over here, but plus 4 and plus 6 are more common. The stability of plus 6 oxidation state decreases down the group, and the stability of plus 4 oxidation state increases down the group. So chemical properties, although have oxidation state with it binded for learning methodology. But as of now, as per the trend that was adopted by me even in the group 17 and group 18, I'm going to keep this oxidation state always intact with these physical properties. So this is what I wanted to give to you in this first part of the video, where we started the chalcogens group 16 initially from electronic configuration to different physical properties and their trends. I am stopping it here in this part 1. After this, in the release of part 2, we will keep the chemical properties, we will keep the anomaly behavior of oxygen, different atoms or elements with which it reacts and forms different molecules, and the properties of these molecules. So that will be in the part 2. As of now, we are keeping to this physical properties which we have already discussed. If you have any doubt in this section, you can contact me as usual. I am there to solve your queries.